In this video, we're going to take a look at the difference between physical and chemical changes. So, by the end of this video, you're going to be able to use evidence to determine whether a change can be classified as physical or chemical. Let's start out with physical changes then. So, physical changes occur when the substance remains the same substance, even though its form or state may have changed. So, a good example of this would be something like when an ice cube melts, it becomes liquid water from a solid state. So, that's a state change, and that would be a physical change. Other examples could be, for example, ripping a piece of paper. You are changing the state, but you're not actually, it's still the same substance. It's still paper. Or stomping on a banana. You're again changing the state of that banana, but you're not actually changing what the substance itself is. So that is a physical change. A chemical change, on the other hand, happens when the original substance is changed into one or more different substances. And those different substances have different properties. So, for example, when copper, such as the copper in a penny, is exposed to nitric acid, new substances are formed. So, what we're going to do is take a quick look at this video to see what actually happens when we stick a copper penny with nitric acid. So, let's take a look. And so here's our copper penny with a nitric acid. And you can see as the reaction starts, we get lots of bubbling, lots of fizzing. And then you can also see this brown sort of substance here, this gas that's being produced. And so that is actually the new substance that is being formed, is this gas. You can also see some color changes. So the nitric acid started quite green, starting to go a little bit blue. We're starting to get some black spots here on the penny as well. The bubbling's continuing. So you can see as this reaction's happening that new substances are being formed. We're just going to watch this for just a little bit longer. So you can really start to see here some of the black spots, especially right here on the penny or right here on the penny. Okay. With the reactions continuing, we're still seeing some of that bubbling, but the bubbling's now kind of coming down. You can really see some of the black here, especially on the penny where it's inside the nitric acid, and then that gas is still being produced. Okay, so that's a chemical change. And so, how do we know that a chemical change is happening? We can actually look for evidence for chemical change, and there are 6 factors that we can look for that will tell us whether we have a chemical change. So, let's take a look at those so that we can see what this looks like. So, signs that chemical changes have occurred. The first sign is a color change has occurred. And what's important to note here is that physical and chemical changes are different than physical and chemical properties. So while color is a physical property, a color change is evidence of a chemical change. And we're getting that color change because we have new substances being formed. So, a really great example is the formation of rust. You can see the rust is a brown sort of color here, whereas the nail is more of a silvery color, if you can kind of see that underneath all the rust. Our second piece of evidence that a chemical change has occurred is that gas is produced. So, in our example over here, you can see gas being produced, which is coming out of this makeshift volcano as bubbles. And so, this reaction here is actually you would put baking soda down in the bottom, and then we're pouring vinegar down into our volcano here. And when that's mixed, it releases bubbles, and those bubbles come up and out of the volcano. Another piece of evidence that a chemical change has occurred is that energy is either released or absorbed. So, an example here is when a candle's burning. You can feel the heat coming out of the candle, and so that would be a chemical change. You might also feel colder, so it's not always heat that you would feel. If you take one of those ice packs and put that on your skin, it would feel colder, and that's actually a chemical change that is happening there. Light is produced is another indicator that a chemical change has occurred. So, for example, fireworks, where you get the sparks coming off of the fireworks, that is due to a chemical change. Two more. So the first one is the formation of a solid called a precipitate. Now, a precipitate is going to be a new word to you. What that means is it's a solid, so a solid that separates out of the solution during a chemical change. So you can see in our example here, we're pouring some liquid down into this beaker. And this yellow substance that's being formed here is actually a solid that is coming out of solution and separating out of solution. Another really great sort of real world example of that is mixing milk with lemon juice. If you've ever done that, it forms curds, which are solid chunks. It's actually pretty disgusting. The last piece of evidence that tells us that a chemical change has occurred is that the change is often difficult to reverse. So, looking at our example here, as wood burns, it turns into a pile of ashes and gases will rise into the air. After the wood's burned, it can't be turned back into its original form. It stays ashes. We can't put it back into logs that we can then reburn again. Other examples of this are things like cooking an egg. Once you've cooked an egg, you can't get it back into that liquid sort of form. Or baking a cake. Baking a cake has a chemical reaction that's happening inside the cake, which we cannot reverse. So, you know that you have a chemical change if at least one of these six pieces of evidence is present. If it's not, then it's a physical change. So, really important to remember with a physical change, the composition of the substance does not change. So, some examples of great examples of physical changes are things like changes of state. So, that could be melting, it could be freezing, could be evaporation, changing its form. So, ripping a piece of paper, cutting it, and so on, and also dissolving. So, dissolving sugar into tea, you still have the same substances. They haven't changed composition. They've just now come together in a solution. So, whenever you see dissolving, that is a physical change. Chemical changes, on the other hand, the composition of the substance does change. So, some examples of chemical changes are burning. For example, we're releasing gases and changing the substances itself. Photosynthesis is another example of a chemical change where plants are taking in carbon dioxide and releasing oxygen. So that's a change in substance composition. And then finally, decomposing. So, an apple decomposing, for example, the apple is reacting with the air, creating these new substances that result in decomposing. That's it for this video. Let's move on to our next task.